In a high-load environment, every single millisecond counts. When your system is processing thousands of events every second, you simply cannot afford to block your execution and wait for data sequentially. Today, I want to show you how to use modern Java to process these operations concurrently and handle this scale efficiently, dropping your response time to an absolute minimum. To demonstrate this, let's look at a typical example. Here is the facade that fetches data from 3 different sources. As you can see here, for the sake of simplicity, each repository exposes the map to simply return the record and imitate the HTTP request delay. In our case, it's 100 milliseconds. With the use of sequential code, the code will be executed line by line, and each operation here is blocking. It's synchronous and sequential, meaning that, well, let's see what exactly it means. Let's fetch data for specific one account in a synchronous way. As you see, it took exactly 3 seconds because each repository has the same delay of 1 second, and as they are executed one after another, hence the whole process takes at least 3 seconds to finish. And now we will be using the asynchronous. As you can see, main difference is that this facade has the executor service field, which provides the possibility to asynchronously execute each of the methods, so they will be running in parallel. Line 24 is actually the place where all these 3 completable futures are being executed, and as this method uses the completable future approach, fetching data for one account in asynchronous way, it will take 1 second. And the reason for this is, let me run the asynchronous one so you can see the main difference. As you see, account data fetching, communications data fetching, and orders data fetching starts first in the asynchronous approach, while in synchronous approach, account data fetching starts and then it finishes. And only after this point, orders data fetching starts and then it finishes. And only after the communications data fetching begins and finishes. So as each method execution waits for the previous one to finish, it takes the whole 3 seconds, while here there is no waiting, they run in parallel, hence time consumed is 1 second. And now if we compare the results for synchronous and asynchronous runs, but having 5 accounts to fetch, the difference becomes bigger in time. You see, it takes the whole 15 seconds, while for the asynchronous approach, for 5 accounts, it takes 5 seconds. So the rule of thumb is pretty simple. If your next step depends on the previous result, you use synchronous code. If you have independent input-output tasks, like fetching data from multiple microservices or databases, always use asynchronous, and this will drastically reduce your latency. Thanks for watching and see you in the next video.